One of the things that really becomes the challenge is knowing when to use which formula. So one of the things that I would highly recommend is that you find a sheet of paper that you can tear out of your notebook and hold on to, or leave in your notebook if you prefer. And let's gather some formulas together. Before we get too many more, so far we've talked about the arithmetic sequence, specifically its explicit formula. And it is a sub n equals a sub 1 plus, in parentheses, n minus 1 times d. We will also talk about the recursive formula eventually. I'm just leaving a spot for that for now. We also have a couple of arithmetic series formulas that we've talked about. S sub n equals n over 2, in parentheses a sub 1 plus a sub n, and S sub n equals n over 2, 2a sub 1 plus n minus 1 times d. Specifically, these are for partial sums of arithmetic series. We'll talk about infinite arithmetic series later. And then so far with geometric, we have gotten to geometric sequences. And we have talked about the explicit formula, which is a sub n equals a sub 1 times r to the power of n minus 1. As we go through, we are going to continue to add formulas. So having a sheet that holds all your formulas is going to be something that's helpful. Now, this is not our main goal today. We've got a couple of problems that we're going to look at that have to deal with geometric means. So 10.3 day 2. Still dealing with our geometric sequences and series. Today, focused on geometric means. Do y'all remember what an arithmetic mean is? It's those middle numbers. It's those missing terms. Missing terms between any two non-consecutive terms, this time of a geometric sequence. Now, just a reminder, when it comes to our geometric means, we don't know where they are in the sequence. We just know that somewhere along the way, we know what a number is, and then all of a sudden we know something else. Those missing ones, those ones between, are the geometric means. Now, when it comes to arithmetic means, finding those tends to be fairly straightforward. Finding the geometrics aren't bad, but they tend to cause a little bit more issue. They're not terrible by any means, but there's one tricky point in particular. We're going to start by finding the three geometric means between 12, 50, and 2. Just like with arithmetic, I highly recommend you give yourself that visual. And also, just like arithmetic, while there are ways that you can do it to kind of think through and use logic to figure it out, you can also use the formula. If it is a geometric means, we're going to work with our geometric sequence formula. Our a sub n equals a sub 1 times r to the power of n minus 1. What are we going to call that thing? A sub 1. What are we going to call this one? Nope, not a sub n. Well, kind of. I just want the little more specific. A sub 5. Now, a sub 5 being 2 does give us a sub n. A sub n being 2, when, what other variable does it give us? N. My bad. The subscript is n, the number it's equal to is the term, which is a sub n. Okay, so I plug in what I know. A sub n is 2 equals a sub n, or sorry, a sub 1 is 1250 times r is what we're missing to the power of 5 minus 1. Because if we knew what r was, if we knew what to multiply by from one term to get to the others, we would be perfectly okay. We don't know that. That's the problem. First thing I'm going to do is that subtraction, and I'm going to get r to the 4th power. How do I solve for r? Where should I start? Go for it. Ooh, not minus, because this is multiply. Divide by it. Does 2 divide by 1250 nicely? No. Do I want it as a decimal? It's not going to help you to have it as a decimal. You're going to want it as a simplified fraction. 2 divided by 1250 as a simplified fraction, and you can use your calculator to simplify the fraction if necessary. It is 1 over 625. You chose the wrong floor, that's why it won't let you start it. How do you get rid of a 4th power? Go for it. Kind of. It's not called a square root. A square root is called a square root because it gets rid of a square. I've got a 4th power here. How do I get rid of a 4th power? Square root gets rid of squares. What gets rid of fourths? Oh, y'all are killing me here. It's called a fourth root. I just had to switch out the one word. We're going to take a fourth root. Fourth root looks like this. It's got a little 4 hanging out in that side, the check mark piece of that radical symbol. Because that's what that is. It's not actually a square root symbol, it's a radical symbol. Except, there's one thing that we have to keep in mind when we use roots. Think about when you take a square root. When you introduce a square root to a problem, what do you have to introduce with it? Plus and minus. Do I have to do that with every root? No. Which roots do I need to do that with? Evens. Because when I take something that is, let's say, a negative number, and I put it to an even power, it's like multiplying that number by itself a number of times that would turn it into a positive. But when I put it to an odd power, I get a negative times a negative times a negative if it's to the third. Negative times negative, positive times negative, it goes back to negative. Even powers will always turn to positive numbers. Odd powers will always keep their signs. As a result, when we undo this, when we take the roots of these, the square root, or in this case the cube root, or in this case the fourth root, or in this case the fifth root, the even ones could be either positive or negative to get a result of that. Okay, in short, when you put an even root, they need the plus or minus. So I put the plus or minus in front of the plain number. Now, do you know how to take a fourth root on your calculator? All your calculators can do it. I type the 4 in first, regardless on if I'm working on a TI graphing calculator, a Casio graphing calculator, or one of the little baby TI calculators. You start with your 4, because that's the type of root you're taking. Then I look for my fourth power. The TIs, it's under math. Do you see the fifth one down has an xth root? That's the one you want. On the Casios, or the little baby TIs, look for your power button. My power button's right here. Gold right next to it is an xth root. Shift, hit that power button. On the little baby TIs, same thing. Here's my power button. Second, that power button puts that on screen. That's not the website not working. That means you can't leave right now because there's too many people out in the hall. Okay, now if I do 1 over 625, make sure you put it in parentheses, unless you've got the fancy calculators where you're putting it directly underneath. My calculator gives it to me as a decimal. Do you think I want it as a decimal? No, not really. Is a decimal the end of the world if I can write it without rounding? No. But I would prefer a fraction. R is equal to positive and negative 1/5. Or if you left it as 0.2, it's not the end of the world here. That is not what I'm looking for, though. I am looking for the means. According to this, to go from term to term, I am multiplying by either 1/5 or negative 1/5. So, to get my actual means, I do the math. I multiply by 1/5. I multiply by 1/5. I multiply by 1/5. I get 250, 50, and 10. And if I do it one more time, it brings me to 2, which means I did it right. But if I have a positive and negative, I should have 2 lists of numbers. One where I'm multiplying by the positive, one where I'm multiplying by the negative. The only difference is going to be positives and negatives. This was positive, multiply by a negative, I'm going to get negative 250. Multiply that by a negative, it's going to go back to positive 50. Multiply that by a negative, I'm going to get negative 10. Negative times a negative is positive. And I was multiplying by negative 1/5. You can also just use the calculator and multiply by negative 1/5, and it'll tell you positives and negatives. Now, one quick note, one quick reminder as we do this. Does the problem tell us what order the numbers had to go in? No. Could I have saved myself the decimals by flip-flopping the 2 numbers in the first one? Yeah. If you want to do that on every problem, do it. Start with the smaller number. Are you always going to avoid decimals? No, because sometimes your constant ratio is going to be a fraction. But if you want to start with the small number and go to the big number, go for it. 7. What comes after 7? Followed by? Make sure you're putting the correct number of blank spaces as well. Burton, once I've got this, what do I do next?
You gotta find the A1 and the A5.
Yes-ish. This is A sub 1, but is this A sub 5?
No, it's 4.
A sub 4. Remember, first term, second, third, fourth. A sub n will be 15, 12. N will be 4. Carly, then what? Plug it into the formula. Formula starts with A sub n. We just said that was going to be 15, 12. Equals. Then it goes A sub 1. We said that was 7. Times. What's R? R, that's the problem. To the power of 4 minus 1. Or if you jump directly to the power of 3, I'm good with that. Sam, now what? Divide both sides by 7. What do you get? 216 equals r to the 3rd power. Kylie, Freitag. Now what? The cube root, or the 3rd root. Aubrey, do I need plus or minus this time? No. No. Miriam, what is the cube root of 216? 6?
Yeah.
R is 6. Just 6, not positive and negative 6. Just 6. I didn't need plus or minus because my root was odd. Wendy, how do I finish the problem? Multiply by 6 to get from term to term. 7 times 6 is 42, times 6 is 252, times 6 is 1512. Geometric means, are they hard? No. The most challenging part is making sure we're solving correctly and when to do pluses and minuses. Page 678, day 2, 35 through 40.